Let's go now to KwaZulu-Natal and Otongati, the site yesterday of that tornado. Lehlohonolo Thobela is a meteorologist with the South African Weather Services. Lehlohonolo, good afternoon to you. How intense was this tornado? Is there a way at this stage or a scale to measure a tornado scientifically?
Good afternoon. Yes, there is a way of measuring the scale, and we're currently busy with that. We've just issued a report about confirming the tornado having happened over KwaZulu-Natal. At least about 2 tornadoes were observed over the past 2 days, over from yesterday into today. And the main one was over the Newcastle area, all the way to also another one was seen around Tongati, the Palito side. And there were 2 different tornadoes. One was like forming in a form of a cone, and another was a wedge like which move over to the ocean. But we are yet to still release one that scale in terms of which type, is it a F01 or which type of scaling that is different tornadoes. Then they're yet to be measured based on the impacts as well as the damage that it has made in an area. So we're still busy with that. Once that's set out, then we send a report out.
Do you issue your sort of judgment of whether it's a tornado or not just on the damage that it caused? Are there other factors you take into account? Are there evidence that you can look at?
Yeah, I mean, part of the evidence and observations are the videos that we've seen. However, we still also look at the atmosphere. Was it conducive? And it goes and correlates with the warning that we had issued of severe thunderstorms, especially over the central and the western parts. So with the system like a cutoff low weather system, it brings about a dynamic number of weather patterns in an area. And whenever we are here to experience weather due to the system, we are here to see severe thunderstorms, especially over the central and the eastern parts of the country. And part of the severity of the storm, then sometimes you have storms that start just minor and then they pick up due to instability or topography of an area and more of the moisture. Most of it, like the one that happened, was due to wind shear in an area. The moment the direction of the wind changes with the speed, and some are also influenced by jet streams, which is a strong and narrow amount or rather or more motion of wind that happens, which results in a tornado like what we saw yesterday. So it's 2 different types of tornadoes that were seen yesterday, all based on the shape. However, more than that, it's obviously the observations on the ground. We see the environment. Was it conducive for it to actually pick up and result in a tornado, or was there any signs of any observation on the radar or satellite images? So there's a number of factors that we look at. But yes, part of it is actually the wind, because I mean, if you're seeing the video that concludes or rather confirms even the damages that you've seen in KwaZulu-Natal, there's no way we can just sit down and not look at the things, especially when we've had a warning sent out. So that's part of the case study that we look at with the warning that you send out. Part of the regulatory of how the warnings go about, we get observations and then give a report based on the warnings that were sent out.
If you have one tornado during a major storm like this, are you likely then to have more than one? In other words, if the elements, if what you're seeing happening in the atmosphere creates one tornado, it's going to create others in the same area?
Yeah, it's mainly. I mean, in the area. So what happened with this system, right? There was a cutoff low weather system over the central parts, which resulted in a squall line, which is a line of thunderstorms. Which then, within a line of thunderstorms, it's a number of storms that position themselves in a line, but each cell then acts differently in terms of the severity. Hence, why you saw some severity of the storm in the Newcastle area was not the same as what happened in Tongati area, but with them both producing tornadoes, it shows that there were supercells, which then results in severe thunderstorms, as we're linking with the severity of the impact-based warning. So yes, we do actually look at the severity, and it differs in terms of cells activity, because yesterday there were storms even around KwaZulu-Natal, but some of them didn't produce tornadoes. Rather than producing a tornado, produced hail, which is also part of what a severe thunderstorm entails. In some areas, there was strong winds and gusts, which is also part of a severe thunderstorm. So in different areas, it did different impacts.
So if we have weather like this, is it possible to know if we're likely to have more weather like this more often? And I realize it takes us down, to quite a difficult discussion in terms of the elements that create this. But are we likely, do you think, to have more tornadoes like this in the near future in KwaZulu-Natal?
Yeah, I mean, in the eastern parts as a whole and the central areas, with continuing, if you think about it, we're from a La Nina season where we had consecutive three seasonal forecasts of La Nina prior to us going into the El Nino. So in the La Nina, we are generally having above normal rainfall, and as you can, I mean, you can confirm with the past April floods that KwaZulu-Natal experienced due to upper air cutoff low was actually the same system. It resulted in heavy rain along the coast as well as some parts of the Lady Smith, which resulted in more of the rain and flooding and a lot of fatalities with this system. Now we have the same system but differently in terms of what it produced severe thunderstorms, which is also part of extreme weather. Now, with global temperatures expected or likely to reach about 1.5 degrees Celsius globally, extreme weather is expected to increase with the number of temperatures as it's expected by climatologists as well as seasonal forecasting, which suggests that with more of the change and El Nino and La Nina and transitions, more of the extreme weather it seems to be increasing, especially over the central and the eastern parts of the country, which is South Africa. Then yes, we are yet to see much more of these system and extreme weather for the more, I mean, for more frequent that it occurs over the area, the more than the extreme weather we are expecting in the most parts of the central and the eastern parts of the country.
Lehlohonolo Thobela from the SA Weather Service. Really do appreciate the time, a meteorologist there. Thank you.